So we used this phrase regenerative agriculture before. Now we will say more specifically what it is. I kept saying it's a way to recover soil health and so on. So we'll see more specifically what that involves. In terms of ranking by 2050, it stands at number 11. The potential to reduce CO2 by then is at 23.15 gigatons, with a net cost of $57.2 billion and a net saving of $1.93 trillion. Okay, so the experts, very well-known experts who have spent decades working on soil health and soil carbon, like Ratan Lal, have argued that maybe more than half of the carbon has been lost across the world. So regenerative agriculture focuses heavily on recovering soil carbon, which actually has tremendous advantages in terms of increasing soil's texture, microbial life, water retention capacity, and reducing erosion, increasing nitrogen capturing capacity, nitrogen fixing capacity, microbes burrowing down and taking nutrients down, and increasing yield, of course, and reducing climate greenhouse gas concentrations and global warming. The Rodel Institute has been the cornerstone of organic farming in the US since its founding in 1947. Based on the writings and observations of Sir Albert Howard, the godfather of organic agriculture, the Institute publishes, promotes, and conducts extensive ongoing research into organic methods of agriculture. So organic methods and regenerative methods are almost the same. Some details there, but the 333-acre farm in Kutztown, Pennsylvania, shown here, was purchased in 1971 by Robert Rodel, the son of founder J.I. Rodel. The land was played out and exhausted, so essentially stripped of its nutrients and degraded soils left behind. Was an inspiration to Rodel to develop regenerative agriculture, systems of farming that are productive but which also increase the capacity for productivity in the future by restoring soil health. He proposed, and the Institute practices, methods of farming that require no external sources of fertility and certainly no chemicals. Okay, it looks like it's tilled over here, but a lot of the regenerative agriculture focuses heavily on no tillage, or what is called conservative tillage. Okay, this is from this paper, which I think is a nice way to summarize some of the benefits and activities of regenerative agriculture. So we are looking at the planet in green, soil in this brown soil color, people appear, and profits appear. So we are looking at food systems level and farm level here. So activities include minimizing external input, so in-farm fertility, that's very critical. Mixed farming, so cover crops and such, which can have many different properties in terms of regenerating soil, fixing carbon, fixing nitrogen, increasing soil moisture, and so on. Acting as fertilizers, supporting microbial life, and so on. Minimize tillage, so that's no tillage or minimize tillage. Crop rotation, which is always good. Monocropping is known to be very bad. Use of manure and compost. Use of perennials instead of the annuals, and other soil activities. So we had talked about perennials before as well. So the objectives are, in terms of soil, to improve soil biodiversity. The numbers, by the way, in the parentheses here are number of peer-reviewed publications that are available in each topic. Improve soil carbon, which is a big thing. Improve soil physical quality, so texture and sandy versus loam and so on. Enhance and improve soil health. Okay. In terms of planet, we regenerate the system reduce environmental externalities like groundwater contamination, groundwater depletion, soil properties degradation, soil carbon reduction, and so on. Optimize resource, actually externalities are other things like bird life that is associated with improved soil health and vegetation, biodiversity, and so on. So remove the soil part. Okay, optimize resource management, so water use, for example, and fertilizer use, nitrogen cycle. Improve nutrient cycling, which also helps coastal waters and groundwater and surface water. Improve the ecosystem, biodiversity, of course. Alleviate climate change, improve carbon sequestration in the soil. Improve water quality and availability. Yes, it does increase groundwater recharge and retain more of the falling water. Improve human health and improve economic prosperity. Okay, this is from the World Resources Institute, which I found kind of interesting schematic looking at full accounting of soil carbon sequestration strategies, which must consider off-farm effects. So there is additional carbon sequestered in these blue arrows, additional carbon emitted in these red arrows, and overall effect on climate relative to business as usual. So this includes regenerative agriculture as well. So business as usual is about growing crops on the farm while the forest is elsewhere. So after scenario 1, your cover crops are being added while yields are not allowed to drop, so you are going to increase carbon sequestration, and the forest is not touched here. The perturbation, they are protected. After scenario 2, you are regenerative practice adding carbon to the soil, but here yield can decline because you are reducing fertilizer use and other enhanced yield methods, for example. And the forest is cleared to grow crops to replace the lost production. So you end up indirectly driving deforestation when you do this, potentially, if you want to meet food demand. After scenario 3, here the scenarios are illustrative examples and are not really exhaustive, of course. Crop residues which had fed animals elsewhere are imported to the farm and mixed in the soil. So here you are going to increase, of course, forest CO2 because of deforestation, whereas here you can increase for CO2 sequestration. So here the forest is cleared to grow crops and grasses to replace lost animal feed, so you're going to increase CO2. So the overall effect on climate is not going to be very clear. So just means that regenerative farming by itself is not a complete solution. It has to be considered in terms of yields, food demand, forest protection, and other things. Regeneration International lists a few items under a global shift to regenerative agriculture and what it can do. It can feed the world, decrease greenhouse gas emissions, reverse climate change. Well, the Rodel report says that, but reverse climate change is kind of a tricky phrase we have to be careful about. Improve yields, no doubt at all. Create drought-resistant soil. Increased carbon, as I said, increases texture and water holding capacity, as well as other nutrient cycling. Revitalize local economies, no doubt. Preserve traditional knowledge. Yes, this is indeed being lost. Nurture biodiversity. Yes. Restore grasslands. Yes. Improve nutrition. Yes. Excuse me. So, impact of regenerative agriculture is that from an estimated 108 million acres of current adoption across the world, we estimate regenerative agriculture to increase to a total of 1 billion acres by 2050. Let's hope this is really going to come true. This rapid adoption is based in part on the historic growth rate of organic agriculture as well as projected conversion to conservation agriculture to regenerative agriculture over time. Organic food is big, of course. There are issues of whether it's affordable for poor people, whether the certification process is honest or is not cheating, and so on. This increase could result in a total reduction of 23.2 gigaton of carbon dioxide from both sequestration and reduced emissions. So you're increasing carbon sequestration into the soil, which is great for everything, and you're also reducing emissions. Regenerative agriculture could provide 1.9 trillion financial return by $1 trillion in financial return by 2050 on an investment of just $58 billion. Of course, selling it politically and implementing it are always tricky, but nonetheless having these numbers modeled obviously helps a lot with decision making, policy making, public awareness, and implementation as well.